Okay, so if I take this number right here, and that's all I do, and I start comparing, let's say, gasoline and diesel and all the different fuels out there, something kind of funny happens. And I'm just going to throw out numbers for an example, but you're going to take gasoline, for example, and maybe it's going to have, I don't know, I'm just going to make up a number right now, 19 pounds of CO2. A lot, compared to this guy right here. Diesel fuel, maybe 18 pounds. Okay? And so when you start comparing fuels, it's like, wait a minute, diesel engines produce less CO2 than gasoline. If that's the fact, why don't we all switch over to diesels? Because they produce less CO2. Well, there's quite a small problem with that analysis. And this is where you get into politicians or salesmen or whoever you want to will want to give you the information that they want to give you that looks good. So if I was selling diesel fuel, I would stop right here and say, hey guys, diesel fuel is king. It's the best. It gives you best fuel economy. It gives you best power. And oh, by the way, it gives you the less CO2 output per gallon or per pound, whatever. So I would say, the problem is that we're not burning fuel by pound. We're not burning fuel by gallons. And when you look at a gallon of fuel versus diesel fuel versus gasoline, as an example, if I put a gallon of gasoline in here and a gallon of did it stop?
It's like, it says recovering data, please wait.
Okay, that's okay. We got to back up here. If I put a gallon of diesel fuel in here and a gallon of gasoline, I actually have more diesel fuel in here than gasoline. Why is that?
It's heavy.
It's heavier. Yes, it's heavier. So what we do then to give you a true analysis of comparison of fuels, we take this data, my CO2 output, and I convert it into how many pounds per gallon of CO2 I'm actually burning. So in order to do this, I take this number, whatever that number is, bring it over here. 2.93 pounds of CO2 was produced, but how much does ethane weigh? And there you guys are going to have to look up in your chart, and what did I tell you? How much does ethane weigh per pound?
6.58.
Say it again.
6.58.
No, that's too high for ethane.
Oh, no, that's ethanol.
2.97, yeah. So I'm gonna multiply this by how much it weighs per pound, which is pretty light. 2.97. So what's 2.97 times 2.93? This is pounds per gallon of ethane. And this is pounds of CO2 produced. So what's that number? You guys have to calculate that for me. 8.61 pounds, there you go, pounds, so pounds of CO2 per gallon of ethane burn. Now, I can take this number and now compare it to other fuels that weigh differently to come up with a more valid comparison. And when I do that, well, gasoline's going to have a slightly lower number than diesel fuel. But if I'm telling you gasoline and diesel fuel are around 19 or 18 pounds per gallon, and ethane is at 8, well, there's a good reason why to switch over to different fuels, because that fuel is putting a lot less CO2 into the atmosphere. Yes, sir.
You're writing that number in the very end of this.
Yes, very good. So what you're going to do with your chart is you're going to come over and you're going to write that pounds per gallon at the very end. Yeah, so that number there goes right there, right? So that would be what, 8.61. What are you going to write in that chart on that page if your fuel doesn't produce any CO2? You'll just leave it blank, just put doesn't produce.
0.
Yeah, 0 is a good number. Yes, sir.
I don't even know this paper when I set up.
Oh, that's okay. So when we calculate the CO2 output of fuel, it's important to, again, take whatever your CO2 output is, multiply that by how much that weighs per pound, which you're gonna have to look up. I don't expect you to memorize every fuel and how much they weigh. You probably should know what water weighs, what gasoline weighs, what diesel fuels weigh. Those are the 3 big ones. Everything else, you can look up on that chart 1-16. It gives you that information, and that's what we have. Questions on it? Yes, sir.
Kind of going back, the equation that you're balancing, the one on the right side,
Mm-hmm.
is that ever changed depending, like, so if we start out with a different,
Oh yeah, if you start with a different fuel, there's gonna be a different number here, there's gonna be a different number right there.
but the base, I don't know, formula before you start changing it around, does that change?
Okay, no.
It doesn't? but you
No,
can change it
so maybe what you're saying is that could I try to balance this somehow by putting like a 4 right there?
Kind of.
Well, whoa. Now that's 6 H2O4. H2O4 could be some acid or something like that.
Yeah.
So if you're changing the little strip behind that, that's changing this to a whole different chemical. By putting it in front, you're just saying I'm using 6 molecules of water versus 1. By putting it over here in the back behind it, you're changing it to a whole different substance. So when we balance it, do not change the base number right there. The two, you don't change these base numbers, because if you do that, that changes the whole entire chemical, that compound. Did that answer your question? What will change is how many of them you have.
But what about CO2? What if it doesn't have any CO2?
Oh, then there you go. You do your formula like that. So, what do you think is gonna happen to this number if you don't produce any CO2? What's gonna happen?
It's going to be lower.
Oh, it's gonna be, well, I still have lots of oxygen, I still have lots of water. If I get rid of the carbon up here, I have to get rid of the carbon in order to get rid of the CO2 there. So all this fuel is gonna make what? Water, and how much water do you think?
More.
A lot. So here's the tip. The less CO2 you produce, the more water you're gonna have. The more CO2 you produce, the less water you're gonna have. Because when you burn something, it's either gonna make CO2 or water. One of those 2 things. And so depending upon how much it makes, depends upon this formula over here. And so the reason why we're doing this is to compare fuels. We start comparing the fuels. And by looking at water output, looking at CO2 output, looking at stoichiometric, that gives us lots of information about those fuels. Yes.
So the carbon, like if you see like a top of a piston is covered in carbon, is that just leftover carbon that hasn't been burned or
Yes.
what? So it's just C. It's not.
Yes.
Yeah.
Okay.
Yeah. So an example, a hydrogen engine. Would you even see any of that stuff in a hydrogen
Probably
engine?
no carbon.
Yeah. So of course I haven't torn apart dozens of hydrogen engines to look at it, but in theory, there's no carbon. So one of the advantages of burning hydrogen in a internal combustion engine, do I have to worry about all that buildup of carbon on the intake valves, on top of pistons, anything like that? Well, it has no carbon in it. So
So how do you have to worry about that in any of the formulas about the leftover carbon? I mean, what's going in doesn't
No.
necessarily mean what's coming out because some's left behind.
no, this is stoichiometric. So this is perfect combustion.
Okay.
There's a lot of
That
times where we
answers
do
my
not have perfect
It's not
combustion.
real world.
As you're driving out of this parking lot, going right up the throttle in your diesel truck, and I see all that black smoke billowing out, well, obviously we are not at stoichiometric anymore, right?
Yeah. Let's go.
And if I am not in stoichiometric, then we have other things that can be produced besides CO2 and H2O. What else could be produced?
NOx.
Well, NOx, that's if my engine gets too hot, NOx could be produced. So if I have NOx, then I'm taking this oxygen and I'm turning it into something else. So now it changes my CO2 output and it changes my water output. What if I have too much fuel, not enough air,
So,
CO, so carbon monoxide. So when I'm my CO2, what's really kind of neat is that I can measure my CO2 output on any given fuel, and if I have the maximum CO2 output I should have, I know I have really good combustion. For like a gasoline engine, anyone know what the CO2 output should be? As far as percent of gases, that's something that we measure on an exhaust gas analyzer. 18%, yeah, if it was up way high, 16% or something like that, I'm real happy. If it's down at 12%, that means other gases are being made besides CO2 and water. Maybe CO is being made. You know, maybe there's excessive oxygen coming out. So you have excessive oxygen could be coming out because you have too much air. You're not stoichiometric. You have CO coming out because you have either not enough air or too much fuel. You have NOx coming out, you know. So when you start looking at a 5-gas analyzer on what it's measuring, CO2 is just one of the gases it's measuring, but it is measuring an indicator of perfect combustion. We want the CO2% to be as high as possible because that's an indicator of everything else is good. Guys have a question on that?
What are these doing?
Okay, well, we can go ahead and close off the video. We don't